Okay, folks, this is going to be kind of a supplemental video to what you guys had from the book last night, just to kind of reinforce what they were looking at in this idea of solving exponential equations. So getting right into it, the major property that we looked at when we solved exponential equations was this idea that if you have an equation with two exponential expressions, where the bases are the same, so you know b's are the same there, and you have exponents with them. If those bases are the same, then you can say that the exponents are equal. So basically what we did is drop the bases, set the exponents equal to each other. And that's what this statement says. If two powers are equal, powers being b to the x and b to the y, and you have the same base, they're both base b, then the exponents must be equal as well. And vice versa, it works the other way too. If you know your exponents are equal and your bases are the same, then those two parts must be the same as well. So our kind of goal in this is kind of our methodology here. We need to make sure our bases are equal, so we have to rewrite our bases in some cases so that they're the same. And that will be thinking of our properties of exponents when we do that. We set our exponents equal to each other and solve. As a little hint, a reminder here, if you have fractions, that usually means a negative exponent was involved somewhere. And our reminder there is, remember, something to a power that's negative is 1 over that power to the positive. So, for example, if I had 1 over 8, okay, that 8 was really 8 to the negative first power. That's kind of what the power there is 1. So those are kind of the same ideas. We have to remember that as we go through and solve these problems. So let's just jump right into it and see where we are at with all of this. So first example, take 2 to the power of x plus 7 will equal 16 to the power of x minus 5. So let's look through this piece again. As we look at our bases, they're 2 and they're 16. They're not equal right now, so I can't just go ahead and set my exponents equal to each other. But we can rewrite them. And the kind of best way to look at that is, let's look at our smaller base. It's 2. And ask yourself, can I write 16 as some power of 2? If you're not sure, take a little space over here and break it down and do a little factor tree. So that's 2 and 8. Well, that's good. There's a 2. I want that. 8 is 2 and 4, and 4 is 2 and 2. Well, if I look, I've taken 16 and wrote it as one set of 2. That's all I have there is 2. That's great for me. That's what I want. All right. So 16 really is 2 as the base, and I have 1, 2, 3, 4 2's there to the fourth power. So when we say rewrite your bases, that's what we're talking about. How can it gives me the same value. 2 to the fourth power is 16. 16 is 2 to the fourth power. That's what we mean by rewriting our bases. I didn't change 2 because it's already as base 2, so I'll keep that as 2 to the x plus 7 power equals 16 is now 2 to the fourth power, and I still have the x minus 5 out there. So I haven't changed the value of this equation. Nothing has changed. But what I'm going to do now is I can write them the same because my base is the same. First, let's clean up this mess right here. Don't forget that when you have a power to a power, we have to multiply. So this really is 2x plus 7 equals 2 to the power of 4x minus 20. 4 times x is x, 4 times 5 is 20. Now that my bases are the same, I can take my exponents and write them equal to each other. So I can say x plus 7 equals 4x minus 20. That allows me to do that. Now we solve for x. So this becomes a basic algebra problem. Subtract x from both sides, add 20 to both sides. We'll get 27 equals 3x. So x is going to be a total of 9. And that is our answer right there. If you went and plugged 9 back up in here and evaluated, you would get the same answers for both sides. All right, so that's an example of when you have to change just one base. But what happens if both bases don't match up? So let's take a look at a problem. 4 times 2x equals 32, and you have x minus 1. Okay. Now, bases are the same, and here's where you got to kind of think. can you write 32 as 4 to some power? Well, you could do 4 times 8, but that's not a power. That's 4 times 8, not 4 to some power. If you did 4 as powers, I have 4, then I have 16, and then I have 64. All right, so that can't be. 32 gets skipped over, because 4 to the first power is 4. 4 squared is 16. 4 cubed is 64. I almost wrote 32, but it's not right. It's 64. So that doesn't work for me. I can't write 4 to some power giving me 32. So in that case, we have to write both of these as a different power. So we're going to break both 4 down and 32 down. And again, the more you do this, the easier you're going to see the connection. Well, 4 is 2 and 2. All right, well, I can write 4 as a power of 2. So 32 is 2 and 16, which is 2 and 8, which is 2 and 4, 2 and 2. 32 has a bunch of factors of 2. So let's write both of these as a base of 2. Well, 4 becomes 2 squared. You got that right here, 2 2's. And then don't forget the power that was already there. 32, I had 1, 2, 3, 4, 5 2's there. So 32 becomes 2 to the 5th power. And again, don't forget the power that was already there. Let's apply our power to a power. So this is really 2 to the 4x power will equal 2 to the 5x minus 5 power. 5 times x is 5. 5 times negative 1 is negative 5. Well, bases are the same. Let's go ahead and set those exponents equal to each other. 4x will equal 5x minus 5. And go through again, solve. So subtract 5x from both sides. We will get negative 1x equals negative 5. So x will be a positive 5. Again, breaking those things down to get what they need to have. Okay, let's deal with one final example here. What happens if we have fractions involved? If you remember that third little bullet point there is, remember when fractions are involved, it's usually negative exponents. So let's just deal with that. 1/9 power of 3t plus 5 will equal 243 to the power of t minus 6. Okay. Now looking here again as we deal with this, I have a base of 1/9 and a base of 243. Let's focus on the 9 here and the 243. Okay. If I look at 9, I'd always like to try that to only change one of them. But 9 squared is 81. 9 cubed is 729. Okay. That doesn't work for me. That's not 243. So I can't write 9 or 243 as 9 to some power. So let's look at 9 and 243 if I break them both down. I know this is 1/9, but let's just deal with the 9 first. So 9, if I break that down, well, that's 3 and 3. So 9 is 3 squared. Let's see if we can do 243 as something now. 243 is 3 and 81, which is 3 and 27. Looking good so far. Which is 3 and 9, which is 3 and 3. Well, I can write that as a power of 3 because it broke down into all 3's. If one of those happen to be different, I can't break it down to that power, so it won't work for me. But this one does. This is 3 to the 5th power. Okay, so I can start rewriting stuff. 1 over 9 is 1 over 3 to the 5th power. And that's all to the 3t plus 5. Well, remember, when you have a fraction, 1 over 3 to the 5th power, if you go back to our original idea, I erased it, so never mind. When I have 1 over a number, that means the power was originally negative. So let's make it negative again so I can use this to my advantage. So this really is 3 to the negative 5th power, and then keep the exponent, 3t plus 5. Okay, I want to do that so I can get my base as 3. 1 over a base is not the same thing as a base of 3. Oh, this shouldn't be 3 to the negative 5th. I'm sorry, I messed it up. That should be 3 squared there. So change that a little bit. Pardon me. 243 is 3 to the 5th power. And then we have t minus 6. So this is equal to 3 to the 5th power and t, it's a negative 2, minus 6. Okay, so as we go through and look at this, now we have our bases equal. Pardon my mistake there, folks. Go back and change that in your notes really quick if you don't have that there. Part of this problem now, I have bases that are the same. Remember, 1 over 3 squared and 3 to the 5th are not the same. Those are not the same in value. We have to make them both 3, and that might involve making your power negative. So then with that, we write that as 3 to the negative 6t minus 10, because negative 2 times 3 is negative 6, negative 2 times 5 is negative 10, equals 3 to the 5t minus 30. Okay. Now I have exponents that I can set equal to each other. 6t minus 10 equals 5t minus 30. Okay, and we'll go ahead and solve. I'm going to add 6t to both sides so things are positive. Add 30 to both sides as well. We will get 20 equals 11t. Divide by 11. So t is going to be equal to 20 over 11. Okay. So that's our process. Again, those are the 3 main things you're going to look at as you go through. But that's the idea of solving exponential equations, excuse me, as you go through. Get those bases equal to each other. It might take some maneuvering and making things with negative exponents even, but that's okay to get back where we need to go to. So that's our idea, and we'll see you on Thursday.